Hello friends, here in this video we will see the helical spring in combination, right? Okay, helical spring is connected in combination. That means it is like a parallel series, etc. Right? So the helical spring in combination, it is two types: spring in parallel, and second one is spring in series, right? Okay, so first we can see spring in parallel, right? Okay, we can draw the figure parallel spring, force F, okay. Here is K1 and delta, here is K2 and delta. Delta means axially deflection, okay, and the final one is summation of it, K and delta, right? It is the simple figure of the spring in the parallel, right? Now what is K1, what is K2? Now we can see K1 is equal to K1 and K2, okay, both are stiffness of the spring, stiffness of spring 1 and 2, spring 1 and 2 respectively, right? Newton per mm, right? Delta, delta 1 and delta 2, okay, this one is delta 1 and this one delta 2. Delta 1 and delta 2 is deflection of the spring 1 and 2 respectively, right? And it is in terms in mm, right? K means this one, K is stiffness of parallel combination, okay, this one is combination, parallel combination, Newton per mm, and delta is equal to deflection of parallel combination in terms of mm, right? Okay, now spring in parallel, right? Okay, we can see the spring in parallel condition, so that's why spring 1 and spring 2, okay, in both the spring, okay, delta 1 and delta 2, the length of the spring is means deflection is same, okay, so that's why delta is equal to delta 1 is equal to delta 2. That means this delta is equal to delta 1 is equal to delta 2 because of the length of the spring, means deflection of the spring are same in all the condition, right? And this one is equation number 1, okay. And force F, actually force F is equal to F1 plus F2, F1 plus F2, and it is equation number 2, okay. Now the stiffness K is equal to F by delta, that is the equation, so that's why F is equal to K into delta, okay, stiffness, so that's why the equation is F means K into delta is equal to K1 into delta 1 is plus K2 into delta 2, right? And this one is equation number 3, okay. Now this equation 1 and equation 2 is put in equation number 3, right? Now equation 1 and equation 2 are in equation number 3, right? So that's why K delta is equal to K1 delta 1, okay, so K1, but delta 1 is equal to delta 2 is equal to delta, right? So K1 delta plus K2 delta, okay. In this equation delta is common out, so it is cancel out, so that's why K is equal to K1 plus K2, okay, it is the stiffness is equal to K1 plus K2, right? Okay, so remember these three equations. F is equal to F1 plus F2, delta is equal to delta 1 is equal to delta 2, and K is equal to K1 plus K2 for the parallel. Okay, and next one is spring in series. Okay, next one is helical spring in series, right? Okay, first draw the figure. Sorry, F spring 1, spring 2. Okay, K1 delta 1, K2 delta 2 is equal to K and delta, right? Force F. Okay, F is in means a total force acting on spring, right? F1 and F2 is equal to force acting on spring 1 and 2 respectively in terms of Newton. Okay, K1 and K2 stiffness, okay, on spring 1 and spring 2 respectively in terms of Newton per mm, and delta 1 and delta 2 is deflection, right, in terms of mm. Clear? Okay, and K and delta is equal to combined stiffness. Okay, stiffness of series combined. We already see in the previous point. Okay, like this. Okay, and delta is equal to total deflection of the series combination. Okay, okay, for the spring in series. Okay, in the spring in series, F is equal to F1 is equal to F2 because in the single direction only. So that's why F is equal to F1 is equal to F2. Okay, equation number 1. And deflection is delta 1 plus delta 2. In this case, the difference is delta 1 is equal to delta 2 is equal to delta. In this case, okay, in the parallel, length is same, but in this condition, length is delta 1 and delta 2 is increased. So that's why delta is equal to delta 1 plus delta 2. Okay, equation number 2. Okay, now again K is equal to F by delta. Okay, stiffness. So that's why delta is equal to F by K. Okay, so F by K is equal to F1 by K1 plus F2 by K2, equation number 3. Now equation 1 and equation 2 in equation number 3. Okay, 1 and 2 in equation number 3, right? So that's why F by K is equal to F by K1 because of the F is equal to F1 is equal to F2, right, is equal to F by K2. So that's why 1 upon K is equal to 1 upon K1 plus 1 upon K2. Okay, it is the condition. So that's why for series, remember this F is equal to F1 is equal to F2, delta is equal to delta 1 plus delta 2, and 1 upon K is equal to 1 upon K1 plus 1 upon K2. Okay, these things, these 2 points are, remember, it's so easy. So it is the helical spring in combined, in the spring in series and spring in parallel. Okay, thank you.